Ben, a chemical engineering student here at the University of Birmingham. Today we'll be taking a tour of Smurfit Kappa's SSK site. We'll be looking into what they do, speaking to a few employees, see how what you learn at university is linked to the industrial world. I'll tell you a bit more about Smurfit Kappa on the way. Smurfit Kappa is one of the largest fibre-based packaging companies in the world, employing over 40,000 people worldwide. The Smurfit Kappa SSK paper mill in Birmingham has been operating since 1862. Their Victorian entrepreneurs, Smith, Stone and Knight, first set it up, where they made paper manually. These days the mill uses a heavily invested, fully automated PM4 paper machine, and it is one of two paper recycling packaging mills still running in the UK. The site runs 24/7, employing over 110 people, working in a shift pattern, only closing Christmas and Boxing Day. This constant operation allows for 220,000 tonnes of packaging to be produced each year, as well as maintaining an excellent standard of customer service.
We make paper in large reels. Generally that goes to a corrugating plant where they will convert it into corrugated board. There are a few other applications that it can go into. For instance, the tubes that you find wrapping paper wrapped around, sometimes it's used in that process. And I've heard of another process, very local to here, where they will mould it using glue into different shapes that will provide corner edges and protective edges for packing various articles in. So generally speaking, it's used for packaging and safe transportation of other goods.
Smurfit Kappa SSK pride themselves on the care they take in the health and safety of their employees and visitors. Any safety concern on site must be reported so the problem can be rectified. They keep a log of how many consecutive days without an accident they are at the entrance. Each person on site is required to sign in every time they come onto site and sign out every time they leave. This is important in case of emergency so each employee can be accounted for. PPE is required when walking around the site. This includes a high visibility jacket and steel toe cap boots, as well as ear defenders near the loud machinery. There are specified walkways pedestrians have to adhere to outside due to there being a high volume of traffic. This is a stockyard of all of the raw materials delivered to, which is all recycled paper. The stockyard has a capacity of 11,400 tonnes, of which 11,000 is baled and 400 is loose. As you can see, the paper is transferred by JCBs and forklifts around the yard, then onto the conveyor. The conveyor transfers the raw materials into the pulper, a type of mixer which mixes together the recycled fibre with water. The pulper creates a rotating suspension via an impeller, and the contaminants are in the paper, such as plastic and metals, tangled onto a rope which is dangled in and drawn up into a waste stream. As the rope is pulled up, it is cleaned to remove any fibres from the waste. The paper fibres remain in the suspension, leaving the pulper with a consistency of 4% fibre and 96% water. Some of the contaminants are too small to be removed by the rope, so they pass through the pulper and go through to a drum sorter which acts like a sieve, removing any contaminants greater than 12mm. These cyclone cleaners are then used to further clean the fibre water mixture after it leaves the pulper. High density particles such as staples that the drum screen couldn't filter out are removed here using centrifugal force. This forces the heavier particles towards the wall of the chamber to slide down to be collected at the bottom, whilst the clean mixture leaves at the top. The paper machine is the heart of the operation. It converts a 1% slurry into paper in an automatic process that consists of three major steps: the wet section, the press section and the drying section. The clean slurry is put onto a permeable mesh wire and sent through a slice, which evenly distributes the fibres across the wire in order to give the paper consistent properties. This then leads to the first stage of water removal. Water falls through the wire and is recycled to reduce water demand. The sheet then passes over vacuum boxes to further increase water removal, leading to a consistency of 20% solids. The first stage of the press section is sending the sheets through two twin roll presses operating at a pressure of 5 bar in order to squeeze the water out. It is then sent onto an extended nip press which has a lubricated shoe acting against a rotating roll operating at 68 bar to further remove water and increase solid content to 53%. The sheets then pass over 54 steam-heated cylinders that use steam with a pressure of around 7 to 8 bar. They alternate up and down so both sides of the sheet get dried equally. This reduces the moisture content to the final 7 to 8%. A forced ventilation shaft then sends the moisture to the atmosphere. This is the most effective way of drying the paper, however cannot be the only method, as this is very cost intensive. From the steam cylinders, the paper is reeled up into 16-ton rolls. At this point, small test samples are taken out of each reel. The plant makes 30 to 40 of these rolls each day. These are then passed over the final section of the main production floor where they are cut into customer orders. These are normally reels weighing around 2 tons with a diameter of 1.4 metres. This is done using an automatic system which slices the paper. This process can be run by just entirely one person. Any of the cuts produced at this point fall onto a conveyor and are then sent back to the pulper for recycling. Once cut to size, the rolls are weighed to ensure they are exactly the correct specification for the customer. They are then sent to the warehouse via an automatic conveyor system for storage before future transportation to the customer. The rolls are then moved around the warehouse by self-guided vehicles, which use lasers as a guide. Employees aren't allowed in the area that the robots operate in so as to not interfere with them. Any interference could result in the need to manually reset them. These vehicles pick up the reels and then put them in their predetermined storage positions, which they know as they are linked into the warehouse management system. Using these vehicles increases safety as well as stock organisation. It also prevents the need for human interaction, reducing the chance of damage or contamination to the product. After the reels are stored away ready for delivery, the process is done manually. Forklifts load the reels from storage onto trucks. The trucks are first checked to ensure they are clean so there is no contamination of the product. The reels then need to be strapped in to make sure they don't move around in transit. This leads to the need for edge protectors to put in below the straps so they don't rub against the paper, causing any damage. Every 30 seconds, samples are taken out of the machine to test properties such as the basis weight and moisture content. These can be used to calculate fibre content. This information is used to adjust the amount of water added at the start of the process to ensure the paper maintains ideal properties. The samples that are taken from the reels are then sent here to be tested. They are tested for numerous properties including strength and colour, as these are the properties that customers are most interested in, so it is important they are constantly maintained. They keep a log of these for a year so they can answer any customer questions about the paper should a problem occur. SSK contract out their stores to Eriks to keep better organisation of their spares. In here there is at least one of each spare part ready for replacement, so in case of damage to a piece of equipment the process doesn't have to stop for long periods of time. The wastewater from the drainage system is sent to an on-site water treatment plant. This uses anaerobic bacteria to remove the contaminants that are in the water. This gives an 85% reduction in pollutants before the water is sent on to Severn Trent for further cleaning. Methane is produced as a byproduct of this reaction during the respiration of the bacteria, which is used to fuel a 900 kilowatt engine that produces electricity to help power the site, reducing the reliance on external energy supplies.
If you'd have asked me this question 30 years ago, I wouldn't have had a clue. But the paper industry is an incredibly energy-intensive process. It uses lots of thermodynamics. We use continuous reaction vessels. We've got mixers and pumps and all sorts, boilers. So you name it, you know, all the bits and pieces that a chemical engineer will do. Probably except mass transfer. That's about the only operation that we don't really take place here, although we do water softening, which is a kind of a mass transfer. So, you know, really everything that we do here relates to chemical engineering qualification.
It's a process industry. I did a chemical process engineering degree, and if you wish to understand what is happening within the process, chemical engineering is a superb foundation for understanding what happens and why these things happen. The whole process is controlled by flows, mass balancers, heat balancers, pressures, efficiencies of pumps and everything else. So through the chemical engineering degree you are exposed to the full range of everything that you need to do to control a process, and all those different variables come together when you're actually manufacturing something, as we are here. So you have to have an understanding and a grasp for the chemical engineering principles to understand what the process is doing, and if you don't understand those things, then troubleshooting and problem solving isn't going to happen, because you're not going to understand that if this happens, this will happen over here. You have to be able to make that link by your understanding of process.
So that's all we've got time for here at Smurfit Kappa SSK. Be sure to check out the links to see how we learn at university is